Hello students, today we discuss the Laplace transform part 6 with the topic solution of ordinary differential equation with variable coefficients. See, this is the formula for solving the ordinary differential equation with the help of Laplace transform. That is, if we apply Laplace on just on one variable y, that is y of s. Laplace of y dash is s y of s minus y0. Laplace of Ly double dash s square y of s minus sy0 minus y dash 0. Laplace of y triple dash s cube y of s minus s square y0 minus sy dash 0 minus y double dash 0. See, here if the derivative is 1, then the power of s is 1. S Similarly, for if derivative is 2, power of s is 2. Derivative is 3, power of s is 3. So starting like that. Then always first y of s, then minus y of 0. If double dash, then s into y0 minus y dash 0. For triple dash, s cube, then s square, then s raised to 0 is 1. So power of s is in decreasing order. Then y0, y dash 0, y double dash 0, and the derivative of y0 is in the increasing order. Okay, so see, this is the just trick for remembering this formula. So this is the formula for the Laplace on derivative y and the respective derivatives. Okay, so let's start with the examples. Solve y double dash plus y equal to t with the initial condition y of 0 equal to 1 and y dash 0 equal to 0. Students, we are going to solve this equation with the help of Laplace transform. For that, taking Laplace transform on both sides of this equation. So, Laplace of y double dash plus Laplace of y equal to Laplace of t. And the Laplace of y double dash, see here the second derivative. So, we start with the s square. So, s square y of s minus decreasing order of s, that is s y0 minus y dash 0. Laplace of y is y of s. Laplace of t is 1 upon s square, which we already learned in the previous lecture, lecture number 4 of Laplace transform. Okay, so now put the initial conditions, initial values in the equation. So initial condition is y of 0 is 1 and y dash 0 is 0. So by putting the initial condition in this equation, we get s square y of s minus s into 1, that is just s, y dash 0 is 0 plus capital Y of s equal to 1 by s square. Now getting y of s is a common. So if we get y of s common, then s square plus 1. Put this minus s in the right hand side. So we get 1 upon s square plus s. By taking LCM, we get s cube plus 1 upon s square. So if we keep y of s as a subject, then y of s is equal to s cube plus 1 upon s square into s square plus 1. Dear students, this is the just basic step for solving the ordinary differential equation with the help of Laplace transform. In all this kind of example, first you have to start with the Laplace transform on both sides. Then apply formula. By applying formula, the next steps, you have to put the initial condition. By putting initial condition, your target, keep y of s as a subject. Okay, so by keeping y of s as a subject, now your right hand side, whatever right hand side you get, then you have to apply inverse Laplace transform on both the sides. But it's not easy to find the inverse Laplace transform of the right hand side. For that, we split this term into two parts. So that is s upon s square plus 1 plus 1 upon s square into s square plus 1. By simplifying, you just get this one term. Okay, see again, the inverse Laplace transform of first term is it's easily available, but for second term, again it's not easily available. There are various methods to find the inverse Laplace transform of this term. But I am going to again split the second term. For that, I just add s square and subtract s square. So there is no change in the value. Now, as this keep this s square plus 1 as a one term. So s square plus 1 minus s square and divide individually. So s square plus 1 upon s square plus 1 cancel. So 1 upon s square, and for that s square cancel. So here 1 upon s square plus 1. Right. So now we get three terms right hand side. That is s upon s square plus 1 plus 1 upon s square minus 1 upon s square plus 1. Now it is very easy to find the inverse Laplace. So taking inverse Laplace transform of both sides, we get inverse Laplace of s upon s square plus 1 is cos t. Inverse Laplace of 1 upon s square is t. And inverse Laplace of 1 upon s square plus 1 is sin t. Now move with the another example. Solve the initial value problem using Laplace transform. This is our this is our ordinary differential equation with the initial condition. So let's start taking Laplace transform of both sides. By taking Laplace transform on both sides, here Laplace of y double dash plus 3 Laplace of y dash plus 2 Laplace of y is equal to Laplace of e raised to t. Now, formula of y, Laplace of y double dash, which start with the s square, y of s minus sy0 minus y dash 0. Similarly, for Laplace of y dash, start the power of s with 1, that is s y of s minus y0. Now, 2 into Laplace of y, that is 2y of s. Now, and the Laplace of e raised to t is 1 upon s minus 1. So, by putting the initial condition in this equation, so we get s square y of s, value of y of 0 is 1, so just minus s, y dash 0 is 0, plus 3s y of s, this y of 0 is 1, so 3 into minus 1, that is minus 3, plus 2 y of s is equal to 1 upon s minus 1. By getting y of s as a common, and we get s square plus 3s plus 2, and they put minus s and minus 3 on the right hand side, so we get s plus 3. Now keep y of s as a subject, so y of s is equal to s plus 3 upon s square plus 3s plus 2. Similarly, for 1 upon s minus 1, s square plus 3s plus 2. The factor of this s square plus 3s plus 2 is s plus 1 and s plus 2. So here we get s plus 3 upon s plus 1 into s plus 2. And for second term, 1 upon s minus 1, s plus 1 and s plus 2. By getting LCM, we get s cube plus 2s minus 2 upon s minus 1, s plus 1, s plus 2. So this is y of s is equal to this term. Now we want to find the inverse Laplace, but it is not easy to find the inverse Laplace of the right hand side. For that we are using in this equation partial fraction. Okay, which we already learned in lecture 4 of Laplace transform. So, by using partial fraction, we can write y of s as a upon s minus 1, b upon s plus 1 and c upon s plus 2. By taking LCM and put the value of y of s on left hand side, and by cancelling the denominator on both sides, we get this equation 1. By putting s is equal to 1 in equation 1, we get a equal to 1 by 6. By putting s is equal to minus 1 in this equation 1, we get b equal to 3 by 2. And by putting s is equal to minus 2 in this equation 1, we get c equal to minus 2 by 3. Now substitute all the values of a, b and c in this y of s. So by putting the value of a, b, c in this y of s, we get 1 by 6, 1 upon s minus 1, 3 by 2, 1 upon s plus 2, and this c is minus 2 by 3, 1 upon s plus 2. So now this is easy to find inverse Laplace. So taking inverse Laplace transform of both sides, by taking inverse Laplace of 1 upon s minus 1 is e raised to t, inverse Laplace of s plus 1 is e raised to minus t, and inverse Laplace of 1 upon s plus 2 is e raised to minus 2t. This is the answer for the given problem. Let's check one more example. Solve the initial value problem using Laplace transform for this equation with the initial condition. Taking Laplace transform of both sides. By taking Laplace transform of both sides, see, this is the formula of Laplace of y double dash minus 3. This is for Laplace of y dash plus 2, and this is for Laplace of y. Now, Laplace of e raised to minus 2t, that is 1 upon s plus 2. By putting the initial condition in the given equation, we get this final equation. Now take y of s as a common. By taking y of s common factor, s square minus 3s plus 2, and this plus 6 minus 6 cancel. So just put this minus 2s in the right hand side, that is plus 2s. Now factor of s square minus 3s plus 2 is s minus 1 and s minus 2. And by taking LCM right hand side, we get 12 plus 2s square plus 4s upon s plus 2. Put y of s as a subject. So y of s is equal to 12 plus 2s square plus 4s upon s minus 1, s minus 2, s plus 2. Again, we want to find the inverse Laplace of both the sides. For that, we are using partial fraction. By taking partial fraction, we keep y of s as a upon s minus 1, b upon s minus 2, and c upon s minus s plus 2. So by taking LCM and put left hand side the value of ys, and by cut the denominator from both the side, we get this final equation. Now substitute, by simplifying, we get this equation. See, this is the same equation, by mistake I put here. Okay, now putting s is equal to 1 in this equation, we get a equal to minus 6. By putting s is equal to 2, we get b equal to 7. And by putting s is equal to minus 2 in equation 1, see, these both equations are same, and this equation is known as equation 1. So we get the value of a, b, c. Now substitute this value of a, b, c in the equation of ys, that is a is minus 6, b is 7, and c is 1. Now taking inverse Laplace both the side, and by taking inverse Laplace transform, we get inverse Laplace of 1 upon s minus 1 is e raised to t. For second term, that is e raised to 2t, and for the last term, that is e raised to minus 2t. Okay, so this is the example for the given problem. Now one more example. Solve the initial value problem using Laplace transform for this equation, and with the condition y of 0 is 4 and y dash 0 is minus 2. Taking Laplace transform of both sides, by applying formula, we get, and here the Laplace of t square is 1 upon s cube, and Laplace of t is 1 upon s square. By putting the initial condition in this equation, we get this equation. Now get y of s as a common, so we have s square plus s into y of s, 2 upon s cube plus 2 upon s square, minus 4s minus 2. So if we keep minus 4s minus 2 right hand side, that is plus 4s plus 2. Okay, now by taking s cube as LCM for this first two term, so 2 into 1 plus s upon s cube and 4s plus 2. Now if we keep y of s as a subject, then 2 into 1 plus s upon s cube into s square plus s, 4s upon s square plus s, and 2 upon s square plus s. So by simplifying here, if we keep we get s as a common, then here we have s plus 1 by 1 plus s, 1 plus s cut. Similarly, if we get s common, then ss cuts. This is 4 upon s plus 1. Here we split last term in two terms, that is 2 by s minus 2 upon s plus 1. Okay, now by simplifying we get 2 upon s raised to 4, 2 upon s, and 4 upon s plus 1 minus 2 upon s plus 1, so that is 2 upon s plus 1. So taking inverse Laplace transform on both the side, we get t cube by 3. Laplace of inverse Laplace of 1 upon s is 1, and inverse Laplace of 1 upon s plus 1 is e raised to minus 2t. So this is the answer of the given example. Dear students, this method is very IMP method, and there are some common basic steps for all examples. So please do that. If you have any query, feel free to contact me. Thank you.